Hello there, listeners. How are we all? Well, it is just me today. There's nobody. He is out, as we said last week. He'll be back next week, and he can tell you all about his little being out. I don't know if I'm allowed to say much more than that, but Barry will shed some more light on where he's been and what he's been up to. But I am not completely alone. It's podcast 212, and we have got the special guest. We've got Shane from MIGRO LED. Now, if you don't know, you need to go and follow him on Instagram, and he's got a big YouTube channel as well, over 42,500 followers on the YouTube channel, and he tests LEDs, and he's very good at it, very honest, and that's what this podcast is all about, is MIGRO, testing LEDs and just talking, cutting through some of the bullshit. So we're going to get into it. Shane's calling in, and we will have a little see what Shane's got to say. But first of all, this couldn't happen without the partners. And we have got a selection of partners to start off with. CANNA, the nutrient range, www.canna-uk.com, the best nutrients that anybody can buy, really. If you're a new listener to the show and you're a new grower, this is the range you need to go to. If you've been having problems with the nutrient range that you use, then you know what to do. You can go back to CANNA because they're always there, trustworthy, consistent, reliable, and it's why they are one of the biggest nutrients in the world today. So thank you very much to CANNA. Now, with a range of nutrients, you need a system to feed your plants, and there's no better system than AutoPot. AutoPot.co.uk for all the information on them. New valve out very soon with 5mm hole, and you can, organic growers, there's some options here for you now. You can start maybe using your organic nutrients such as your bio range from CANNA with the new valve, and it's been tested and it hasn't missed a heartbeat. So AutoPot watering systems, go and give them a follow on Instagram, AutoPot_global. And if you need a system that waters your plants with no electricity required, this is the system for you. Phenomenal. Thank you very much to AutoPot. Now you've got your feed and you've got your system. You need to light your plants up. And to do that, you're going to use, in the summer and potentially throughout the rest of the year, you're going to use SANlight LED, SANlight.com, to go and check out all of their fixtures and what they have to offer. We're in the summer right now. There's no better choice than SANlight LED, in our opinion. The quality of the build, the people behind the company, everything is just absolutely spot on. And we love our SANlights, and they're the biggest seller in our shop. So big shout out to SANlight, and thank you again for partnering up with us. Now, you have got your feed, you've got your system, you've got your lights. What's going to happen if you don't do anything else? You're going to have high temperatures. To get rid of them, you have CAN filters and fans, Isomaxes, Qmaxes, CAN lights, CAN originals. They've got everything you need in every size and every power that you need for your room. And there's no one better. CAN originals, they'll last for 24 months. They're a bit heavy, but they'll last. And you've got your CAN lights, 12 to 18 months, and they're a bit cheaper, a bit lighter, but they just don't last as long as the originals. But the CAN lights are a phenomenal filter, and it's the biggest selling filter in our shop. Now, where do you put all of this stuff? You've got your filter, your light, your system, your feed. Where do you put it all? Well, you put it inside the BudBox grow tent. They are BudBoxGrowTents.com to go and check out the sizes that they've got. There's over 30 in silver or in white. The Pro range is what you need to be going for. Don't be settling for silver reflective material. It's all about the white. And it's not just any white, it's BudBox Pro white. All you need to do is go out, buy a tent of the size that you need. Top tip, measure the size of the space that you've got. Don't go into your shop and say, I think I've got this, and stretch your arms out. They'll just get funny looks. Measure your space and go and ask for the right size BudBox that you need. And last but by no means least, you've got Gavitas. Now, LEDs, they might struggle during the cooler periods of the year. And if you're in the UK, that tends to be 11.3 months of the year, tends to be cooler than warmer. But Gavita have got you covered. So whether it's 600 watt single-ended lights all the way up to 1,000-watt double-ended fixtures. If you want to go to ceramic metal halides, and they also have LEDs available if that's what you want from Gavita. But the big standout product for me from Gavita is the 6750 double-ended flex. And we found out that flex actually means that the Gavita light is as efficient as any 600-watt light when you dim it down to 600, but it is also the most efficient at 750. It's a very versatile light. If you're looking to get the best physical light you can with the most options, you go for the Gavita 6750 double-ended flex. Dims down to 500, can go up to 750, and it's actually got a boost feature of 800. So phenomenal lights. Very proud to have them on as our partners. And we have Garden Culture magazine. When you've got all of this kit, you've got your CANNA nutrients, your AutoPot system, your SANlight LEDs, your can filters and fans for extraction, your BudBox tents, and your Gavita lights. What do you do with all? Well, what you do is you go and pick up the free copy of Garden Culture magazine. Or you can just visit the website, gardenculturemagazine.com, to see the blogs and see the articles, and you learn how to grow. You learn all about growing. And the best of all, it's free. The magazine is free, and it's a brilliant magazine. So thank you very much to the partners for this episode. It is 212 with MIGRO LED. Sit back, go make yourself a cup of tea, and enjoy this podcast. And we will see you all after the break.
All good? Ready to go? Turn my voice up a little bit. Oh, I've got everyone watching, the whole family.
Are you ready to go? Are you built to be in the house that I built, in the booth that I built?
I know people tune in every Sunday to listen, but even when business is good, we still manage to do the podcast.
So here we are, podcast 212 with MIGRO LED. We have Shane. If you're a listener of the podcast and you don't know who Shane is, then you're obviously not really into LEDs, because anyone who's into LEDs knows MIGRO. Check them out on YouTube. It is MIGRO. It's the Grow Lighting channel. And if you need to know about LEDs, then this is the channel for you. It's no bullshit. We've got Shane. How are you, buddy?
Yeah, Stephen, very good. Thanks for having me on.
No problem at all. Thank you for coming on. So unfortunately, I'd have had you sat next to me, and would have had a good one-to-one chat. But it's I think for the foreseeable future, a lot of our interviews are going to be done over phone. So it's a shame I couldn't meet you in person, but I'm really made up to have you on the podcast.
I would have been very happy to have an excuse to get over to Liverpool for a podcast and a few pints.
Yes. I wondered what was going to come first, the podcast or the pints. So, first of all, introduce yourself. Let's get the social media, the website, and your YouTube channel. So, anyone who's just listening and wants to sort of see who you are, maybe check out some of your videos. What social media websites and YouTube channels have you got?
Yeah, appreciate it. Yeah, so MIGRO, MIGRO, is the channel. We have a YouTube channel and an Instagram page, as well as a website. We're also a grow light manufacturer.
Excellent.
And across the channels, we try to cover all things grow lighting related, really. So we have how-tos on setting up your grow lights. We do lots of grow light reviews to help you be able to buy the one that you need, the right one for you. And we also have guest technical people on helping us with biology and plant biology and lighting tech and all that stuff. So it's a bit of everything.
Yeah, and what I will say is the first thing that people say with YouTube channels, you've got a big YouTube channel, you've got 42.7 thousand subscribers, and what people say is, well, he's got his own LED, so how do you know that the test he's doing are good on all the other LEDs? But I'd like to sort of, as well as your thoughts on that, I'd like to sort of come forward and tell people the reason that I wanted you on the show, because I love your YouTube channel. And I was searching through the videos before, and you might be able to help me point it out, but you launched a MIGRO LED, and then you tested the Lumitech LED. And you actually you in the video, if I remember rightly, you were like, "Oh, this is not a good day for me because it's the Lumitech Zeus 600 watt and it's just done phenomenally." And tell us a little bit about that video because that's a great video for people to show them how you are unbiased and you're not just promoting MIGRO.
Yeah, well, the long story is when I got into LED grow lighting and trying to sell it, basically found it quite difficult because if you're particularly 4 years ago, 5 years ago, if you had a good quality product, they were very expensive relative to HID, and it was a hard sell, to be honest. So, it was trying to convince people what you were selling. First of all, did what it said it was going to do, because there was a lot of LED companies were claiming lots of different things and weren't really delivering, and people were getting disappointed, including me. I bought a few dud LED lights myself, and it was part of the motivation to start building them myself.
Yeah.
When it comes to reviewing them, there are a few LED grow lights that I review, which are lights, I should say, that can be used as grow lights that I would review that are not sent to me, but most for the last couple of years have been sent to me by manufacturers.
Yeah.
And they're sent to me by manufacturers because they have trust that I'm going to represent their grow lights fairly, and I'm going to test accurately and report the figures accurately.
Yeah.
And that's all part of the sort of building first of all, being able to sell you. If you're selling high quality lights, you need to be able to show people what the value is. And the value is in the efficiency and the output and the quality of components. Then you're trying to justify the price, and that's my own sort of narrow view on it, and trying to help myself, my own company. And the broader view then is for people who subscribe is I think they find it useful to have somebody online who's testing lights and in a way that they're able to compare lights across different types. And with the testing procedure that I use, I try to be fair, so give each grow light the opportunity to perform as best it can. So hang it at its optimum height, use it in reflective environment, and set it up the way it should be. And then I just don't lie, which seems to be something
novel,
unique. Or
Well, we're going to touch on all those sort of a few of those points that you've raised. But one of the words that you used that I really like, and you don't hear people talking about it because a lot of LED manufacturers and people and resellers will use language to their benefit, but you use a certain word and you say, this light is the best in its class. So I don't think I've ever heard you say this light is the best, just the best. I think it's good to differentiate and say in its class, which might mean if you're after a LED that's under 250 watts or you're after a really high efficiency LED, then there's different classes of LEDs out there. And I like that you use that word because you're not just saying randomly, this is the best, it's great. You say in its class, this is the best. And I think that's what people need to get to. Now, the reason that I wanted to get you on the show, Shane, was because with everything new, and I know LEDs aren't new, but they've really this year, for a couple of years, I've said I think 2020 is going to be the year of the LED and the start of its rise to prominence and taking over from HPS. And with that comes profit and greedy businesses and shady marketing, where they will take bits of the science that help them to sell the light, and it eventually becomes very, very confusing to end users, growers, who then find it difficult to cut through the bullshit. So hopefully what this podcast will do for our listeners will give them the tools that they need to be able to cut through some of the bullshit that they're going to experience when they're trying to pick their LEDs. And one of the things I wanted to ask you was about the early LEDs. You said you started a while ago because some early LEDs were just terrible and you thought you could make something better. So in your opinion and experience, why do you think the early LEDs failed to flower the plants so spectacularly? Why do you think they were good in veg, but what were they lacking to make them so poor back in the day?
There's a combination of a few things. I think, first of all, they weren't as efficient as was claimed. So the first LED lighting I would have bought for growing would have been about 6 or 7 years ago. And I bought stuff direct from China, with all the promises of the world in terms of on the websites and that. And got them in, replaced the HID that I was using. I was replacing the HID. I was 600 watt HPS digital ballast in 4x4. That was my setup.
Yeah.
And replaced it with, what was supposed to be the equivalent, which was about 400 watts of LED at the time. And, just had a disaster, I think I went through two cycles of growing. First one, just blame myself. Second one, I think I bumped it up and got some extra lighting in there, LEDs, to try and supplement. Again, blaming myself. And then finally, as an engineer, I just got, yourself, you're going through 16 weeks here for,
I know, to get
you're 4.5 months down the road. Well, you're probably halfway through flowering and you're squeezing the buds and they're all airy and fluffy and you're starting to get worried. But, so that was very disappointing, very frustrating. And so I said, look, I can't afford, for lots of reasons, for this to happen again. So I put the sort of engineering hat on. I'm a manufacturing engineer by training. And so I went and bought myself invested fairly heavily in what's called a power sensor.
Yeah.
And a power sensor basically measures the light accurately. And it's the light that plants use.
Yeah.
So it's the one that's useful for assessing a grow light.
Mm-hmm.
And I think at the time there still is online, but at the time it was the benchmark for me for grow light testing. There's a US chain store actually called Monster Gardens, and they had like a lighting lab in their store, and they used to test different fixtures coming in, the early LED stuff, and they published the results and their test procedures and all that stuff. So I can remember spending hours and hours watching their videos and getting up to speed and getting the power sensors out and buying the test equipment and setting up my own procedure and all that stuff. So I tested those lights that I got and I found out they were absolute rubbish, like a fraction of the efficiency and the output of the equivalent HPS.
Mm-hmm.
And so it got me wondering, and then I sort of wandered into the DIY market, because at those days the LEDs were still very expensive, much more expensive than they are today. And so I started buying them from engineering shops and engineering wholesalers, and just making up them myself, and then testing those. And I think a lot of listeners will probably know of Grow Mouse and other people like that were and Green Jeans and others who were online that were pushing the DIY back in the day.
Yeah.
But so started with that, and they were pretty still, even though you weren't paying for labor or all the assembly costs or anything like that, they were still pretty expensive.
Mm.
And but possible to exceed the efficiency of HPS just.
Yeah.
And about 4 years ago, a bit like microchips for computers, and that you get this continuous development of the LED efficiency over time.
Yeah.
And about 4 years ago, they increased their efficiency on the market by about 30-35%. And pretty much all the big brands, so the Samsungs and the Crees and all these guys, made that sort of step improvement around the same time. And that's when I realized, okay, these are now viable.
Yeah.
They're now able to exceed, like HPS is a very efficient lighting tech,
Yeah.
And it was very, very good for a long time. And it's still very cheap in terms of bang for buck, if you want to get set up quickly and cheaply and fast, it's still the way to do it. But so it's only really 3 years now since we've actually had the means to far exceed HPS technology.
Yeah.
And then the next thing after that was cost. So, the manufacturers were charging too much. We didn't have efficient designs. We didn't have high volumes. We didn't have all those things. And that's now improved, and the price is coming down. So you're getting continuous improvements in efficiency, but the main thing really is the price is coming down, and people are starting to be forced really into publishing accurate data for their lights.
Yeah.
And I hope that I've contributed to that, about highlighting to people that you need to have proper test data for the light that you're choosing.
Yeah.
And the manufacturer should be publishing that and showing you what the test data is. And that's why manufacturers send me their lights, because they want somebody to verify that, they've spent a lot in their components and their design and everything else, and they're happy to send it to me just to get third-party proof, basically, that their light is a good light.
Yeah. How efficient do you think LEDs will go? Like when you said there was a 33% increase, was that basically the big rise up? If it was on a graph and it was a bell-shaped graph, do you think we're well on our way to the peak, or do you think there's a long way to go in terms of LED chip efficiency?
I don't see any huge developments on the immediate horizon. So the actual technology we're using in terms of the LED structure and the materials and the wafers and the manufacturing processes and all that stuff has been very similar for the last 7 or 8 years.
Yeah.
And they've really been refining that. So just making incremental improvements on it, but they haven't really changed the basic tech in at least that long.
So it's just that
we're
the
kind
chips
of
have come
leveling out
down.
On,
is it because the chips have come down in price? If we sort of said, like, you've got A chip, which is cheap, B chip and C chip. 7 years ago, people weren't able to even afford the C chips. The C chips came down in price, and literally it's the reduction in price that means that people can afford to buy them in bulk, put them into the LEDs, and that's why the LEDs have improved.
Well. So if you take that, the LED tech is the same. So it's basically a little sandwich board of different materials with 2 little wires attached to it, and when you put electric current through it, one of those little boards there that's sandwiched in there emits photons when it's powered, when it receives power, and it's not a whole lot different than the old school incandescent, where you had a piece of wire and you ran current through and it heated up and light came out. It's a bit more sophisticated than that, but the principle is very similar. But there is a characteristic of those LEDs that if they're run at lower current, they run more efficient. So if they're run cooler and at lower currents, you can get more photons or light out of them per watt, or for the amount of electricity that you're putting in when you run them lower. Because they were very expensive in the old days, 5 or 6 years ago, they used to run them quite high current, and that meant they weren't very efficient. As the price came down, they started putting more and more LEDs into these little packages. Yeah. So the cobs were a classic example, these round LED packages that have lots of little individual LEDs in them. They basically the next generation would just have more of the same LEDs packaged into a smaller space. Yeah. Or into the same size space, and that would mean that they're running the individual LEDs at lower current. Okay. And so that improved the efficiency dramatically. After that, we've really been messing around with driver technology. So the transformer is required to take the voltage from the wall and convert it into DC direct current, which is what's needed for the LEDs themselves. So those power supplies have improved. And then the system efficiency, which is basically how the light is spread out and how it's delivered. So using lenses, using reflectors, spreading them out with light bars, all that stuff. That has improved efficiency and output as well. And then using more LEDs, so literally more LEDs, driving them lower. So it's been sort of incremental little improvements in each area, but I don't know of any new technology just out of research papers or anything like that. Yeah, that's on the horizon today that we could see filtering into the market in the next 3 or 4 years. Yeah, the commercial market that we could be using. I haven't seen that, so I'm not sure. It doesn't mean it's not there. I just may not be plugged in to know. But I don't see. Yeah, I don't see huge dramatic improvements on the near horizon. So the
Yeah.
next 2-3 years, it'll probably be more refining the designs and getting the price down.
Yeah, that sounds good, and sounds like we're at a good stage with LEDs. Now, before I want to talk to you about Cobb and something else called SMD LEDs, but first of all, we've got sort of straight into it, and I'm interested to know about sort of the history of MIGRO. How come you started the YouTube channel, and what is your background? You've said it was engineering, so what sort of engineering have you doing? How did you end up getting into lighting?
Yeah, so manufacturing engineer by training, as I said. I worked then for commercial companies. I worked for wastewater treatment. I worked for lift engineering companies for years, and sort of corporate stuff and management stuff and all that. Was kind of dying a death, I have to say, dying on the inside and just not interested in it and didn't really enjoy it. Yeah. And got through the recession okay, made it through to around 2014, 2015, and just as I was pretty fed up with what I was doing, and I was looking for something different. And the company I was with at the time was restructured, reorganized, and was offering redundancy. So I stepped forward and managed to get that, which was a nice little package, which package of money, which enabled me to a little bit of time off and to try and do something. So I thought, if I don't try now, I never will. And had a go, and it was always a big hobby of mine growing. Love it, love horticulture. All things science related, really. And when I was thinking about what to do, I was around at that time. It was around that time I was saying I was doing DIY stuff, and it's just really a natural transition, really, to say, look, if I'm doing this for hobby, I obviously enjoy it, and I'm able to do it, and I've got a bit of an aptitude for it, and I enjoy the growing as well. So why not put two and two together? And I did. So I started it about 5 years ago. Took me about a year to get the first lights in development and get the company off the ground and all that stuff, and started selling. So it's been about 3.5, 4 years now selling lights.
Nice. And with the YouTube channel, did that just come along naturally, or was that something that you just wanted to do?
Well, part of the reason I wanted to get away from working for somebody else was to work for myself and not anybody else, and not have to sort of answer to anybody. And to do that, you have to sell your own stuff. You have to be able to get up and sell. And I would be, introvert. I'm not having a big network list. I don't go out and networking and have a big Rolodex with lots of important names in it or anything like it. So I had to think about, well, how am I going to get out and let people know about the lights? So YouTube was an obvious way to do that. And in combination with that, then, as I was saying earlier, I was trying to demonstrate to people the value of the lights. And the only way I could think of doing that was to do what I'd done up to that point, which was to do the testing and to start comparing my lights against other lights. It was HID at the time, really. LED versus HPS was the big sort of key phrase at the time.
Yeah.
For people transitioning over and being convinced to transition over. And started doing that, and saw some traction and some popularity with it. People were interested. They liked the sort of. I have to say, my early ones now are. I find it hard even to watch them myself because they're just they're boring.
Yeah, it's the same as our early podcasts. It's I don't think I've listened to the first maybe 30, 40 podcasts I haven't listened to in years, because it's bad. It's bad. When you're just getting into it and you're just doing it, it was really just for the sake of it, to answer questions. And it got a bit more serious, and now you daren't go back into that cave of episode 4. You just don't want to go there and listen to what it was like. So I absolutely know, and I know where you're coming from on that one. And
do you know one of those things they say about internet comments, and internet comments are cruel and all that kind of stuff? Well, they made me better. Because I was terrible. And I still don't light the place on fire, but I managed to get across stuff without pissing people off now, which is success for me. Because where I came from was I was dry, I was slow, I was boring, I was just tedious to get through. But some people stuck with me. I think they were desperate for accurate information.
Yeah.
Just started growing a reputation, and understanding what people wanted in terms of information and how to present it, and sort of refined it now a little bit. So
it's a good channel.
Hopefully the experience is a bit more enjoyable when watching a grow light review or whatever else I'm up to these days.
Well, you don't get 42.7 thousand subscribers by having a shit channel, so it's sort of that's your credibility right there. You know you're doing something right.
To anybody who's doing this sort of stuff, though, you've got to put in. I don't know what it was like for you, but it was 6 months or a year before I got to the point where I was able to do them and not be cringing watching them myself.
On the podcast, it was. I think people think you get figures straight away. We're doing quite well now, and for our little niche podcast, we average 60,000 downloads a month. We're in over 100 countries and over 100,000 subscribers. But those figures are recent figures, and we had a massive jump in 2000. I can't for the life of me figure out what happened or what we did. But in late 2018, we had a huge jump, and but for I'd say the best part of 3 years, we were only averaging 1,000 downloads a week. Do you know what I mean? 1,000 to 2,500 downloads a week for the first 2 or 3 years, and then it was like it went really, really big quite quickly. But we didn't look at the figures. So if, like you say, if anyone is out there with YouTube channels or podcast stations or they're doing or Instagrams, you've got to do it. And this is why people say you got to do it for the love of it, because if you do it for the viewing figures or for the listening figures, you would probably drop out, because 3 years is quite a substantial amount of time to put your work and effort into. And if you looked at the figures and you thought, this is pointless, then you drop off. But if you're doing it because we started the podcast because we just wanted to answer questions that honestly we were fed up of answering in our shop, like why are plants going yellow? So we thought, we'll do a podcast, we'll answer all these questions and direct growers to this to get the basics, and it just sort of went from there. And you can tell you've done it for the love of the LED and the love of the plants as well, because it just comes across in the station on your channel and all the information that you give across. But firstly, I want to give some what growers want. I want to what our listeners want. I want to give them sort of a good. I want to give them something to take away, and the one that I want to give them to take away is how can they quickly judge whether an LED is a bit of marketing bullshit or whether it's got the potential to be good. Now, obviously, you can't say, nobody can say by the box or the statistics this is going to be a phenomenal LED. But I want our listeners, I want them to be able to have some facts or some knowledge that they can look at a light, look at the stats that it comes with, and sort of say, and have the knowledge to go, well, actually, that's probably not going to perform that well, or the figures that you've given there make no sense, and give them the tools to help them weed out the marketing bullshit and what is potentially a good LED. Do you have anything?
Absolutely. So I'll start with a controversial one, but I think it cuts through a lot of the BS that people have to deal with online.
Yeah.
And it's on spectrum.
Okay.
So spectrum is the light color, and in short, it's made up of blue, green, and red.
Yeah.
There's purple and yellow in between, but that's basically it. And so if you get your standard house light bulb and you switch it on, and it's a sort of a warm white, so it looks kind of orangey, nice and soft on the eyes at night time.
Yeah.
It'll probably have about 10 or 15% blue, and the rest will be a pretty even mix of green and red.
Yeah.
So probably about 40%, 45% of green and red.
Mm.
And that is a standard white, warm white or neutral white. You can go up to a cool white, which is 4 or 5 thousand K color temperature, just a cool white, so that will look kind of bluey and be a little more harsh on the eye. So I'd use that in maybe offices during the day or whatever. That light has a little bit more blue in it, maybe 20% blue, but it'll have the balance will be green and red. And then you can have a very, very warm white. Oh, by the way, that would be about the same as the old HID, the metal halide bulbs we would have used. That was around 20-25% blue. And then you go down to very, very warm white, which is like high pressure sodium is a good example. So about 2000 K color temperature, and now that has quite a low amount of blue, about usually about 3%, maybe 4% blue. And the reason I'm highlighting the percentage of blue is because blue is an important part of the spectrum to regulate plant growth. So when you have no blue in the plant spectrum, in the light spectrum, plants can do what's called stretching.
Yeah.
So if you grew two plants beside each other, one under a very warm white light, so with a low amount of blue, the plants, if there was the same quantity of, and the other one was a cool white, and if you're putting the same quantity of light to both plants, the one in the very warm white with low blue would grow very tall, and it would be stretched, what we call stretched. So it would have large distances between the branches of the leaves. And, typically we don't want that because we're growing indoors and we have limited height and we want compact plants. So once you're above basically HPS spectrum, which is a very, very orangey, warm white, and you're into neutral whites and cool whites, your plant development, so the shape of the plant, is going to be what you want. It's going to be short and dense. After that, there's nothing. No, and by the way, the difference between maybe a fairly warm white, so a bit above HPS, so maybe 6-7% blue, and 23-24% blue with a very cool white, is very, very little difference. So once there's a minimum of 5 or 6% blue, the plants will grow regulated and short.
Okay.
So that's great.
Yeah.
That means we just need a white light. I think the blurple lights are gone now. I don't really see them around anymore. So you don't sort of have to explain the blue-red thing anymore. But I wouldn't, for anybody listening, I wouldn't bother with those. And not because of the colours, the red-blue thing, which is horrible to look at, very hard to inspect your plants, but they're generally much less efficient than the new white LED light. So white LED light, as long as it's got, it's not a total warm white, it's neutral or cool white. So when you kind of see in your use for your living room, they're absolutely fine. But then there's additions to that. So the power spectrum, as I said, blue, green, and red. If you go beyond that in terms of wavelength, so you go up to infrared, which is out past red, far red, and infrared. Far red is also photosynthetic, so it will contribute to plant growth, but it can promote stretching again. So it's not really wanted. Lots of people will sell it to you, and they'll sell it to you saying it enhances flowering, and it does this, and it does that. My view is it doesn't, and it's also a waste of money, in that you're far better off spending your money on getting photons that, in the blue, green, and red range than up in the far red range. And it's similar for UVA. So UVA is included on lots of grow lights, so little UVA LEDs. They're very, very low efficiency UVA LEDs, and it is very questionable as to whether UVA does anything for plant growth. LEDs don't produce UVB, you can't do it. So UVB is helpful for affecting plant growth in that it can trigger the plant to create more oils during the flowering stage and therefore be more potent. But that's not available from LEDs. So with an LED grow light, just go for white, make it a neutral or a cool white, and not much else to worry about. People do add red LEDs into the spectrum. I do it myself. That's done because red LEDs are highly efficient. It's Osram red. They're highly efficient and they increase the efficiency of the fixture overall. But the little spike of red that you see in a spectrum graph for LED grow lights doesn't affect the plant growth at all. It's not going to. A lot of people think it enhances flowering and all this stuff. It doesn't. It's just a bit more red light, a bit more efficient for the fixture overall. So spectrum. Just get a white LED. You'll be grand. If you see UV and far red LEDs on them, it means you're spending money on LEDs that aren't really delivering plant growth. So you're far better off just going for plain white ones, and those supplementary reds, if they're provided, will be good for efficiency.
What are your thoughts on these phosphorus coated lenses? So they use a blue light a blue LED chip passes through the phosphorus coating and it splits it into white lights. Have you come across many of them, and what are your thoughts on those?
Yeah, so they are. If you get a white LED,
Mm.
it'll have an orange surface, and that orange surface is that phosphorus coating, and what's underneath is actually a blue LED.
Mm.
So the blue light, the blue LED emits blue light, and as it goes through that phosphorus coating, it's actually energized the phosphorescence to emit a broader spectrum of light.
Mm.
So it causes like a chain reaction. And depending on how much phosphorus is in that coating, it will either generate a cooler or a warmer white light as a result. So all white LEDs are actually blue LEDs with a phosphorus coating on top. And that's what that orangey, sort of yolky coloured coating is over the LED.
Yeah. And then that sort of leads me nicely on to the next question about COB LEDs or SMD LEDs. COB is the chip on board, and then the SMD, and I always forget this. You know what? I've looked it up hundreds of times. I looked it up 6 hours ago, and it just seems to be a word that my brain doesn't want to remember. What does SMD stand for again?
Surface mounted device.
That's the one. I just don't know why my brain just refuses to learn it. Chip on board.
Yeah. It's a terrible term, and it's not helpful to anybody, and it's more confusing than anything else.
Mm.
So I try not to use it just because you try to explain something by using that phrase, and it just makes people more confused.
Yeah.
But basically, SMD is when you see a board. So generally you see a white aluminium board, and it's got lots of little LEDs mounted on it, and that's SMD. And then COB is getting all the LEDs into one little package. And it's usually a white square with a round yellow circle on it. And inside that yellow circle is a lot of individual LEDs packaged together. The big difference between the two is the COB LED, where it's all in one small round disc. They can be lensed. So if your light source is positioned far away from its target, COBs are very good because you can put a lens over them and you can direct that light quite narrowly. So, for example, street lamps, high bay lights, so the ones that you see up in garage forecourts and warehouses and that type of thing, they tend to use COBs. So they're a single point of light with a glass lens over them, and they're directing that shaft of light, a narrow shaft of light down onto a target below. So it's kind of a spotlight configuration. The SMDs, because they're spread out on a board, it's very hard to lens them efficiently individually because you have to provide loads of little lenses over each little LED, so that's expensive and cumbersome. So they're very good at just blasting a whole load of light out. Not in all directions. They have about 120 degree arc of light.
Yeah.
So if you have one of those boards hanging over your tent, or hanging over your grow, I should say, you have to hang them quite close to the plant canopy because the light is spreading out in all directions, and a lot of it will be going just to the side walls of the tent. And it's why really you need to always use reflective mylar on those side walls, because a lot of your light you're relying on it hitting those side walls and being reflected back onto your plants to have as an efficient and effective a system as possible and to maximize your yield.
Yeah. What's your preference for COB and them surface mounted devices?
Well, it's a very good timing for that conversation because we've been manufacturing and selling COB lights for the last 4 years and just switched over to doing SMD, so the smaller little LEDs on a board. It's actually on bars. So, up to, recently, I would have said that the COB arrangement is the most effective and efficient, and it's the best. However, I've been totally convinced by the SMD. A lot of it is down to efficiency. So the LEDs currently available in those for the boards, for the SMD boards, are more efficient. than the cobs are currently, but also the form factor. So the physical shape you can put them into means they're a lot easier to keep them cool. We're using very high power LEDs for growing. And it's a lot cheaper because you basically need less aluminium to use as a heat sink to get the heat away from them. So there's a number of factors, but and a third aspect to it is it used to be that those SMDs, we would cover them with an acrylic sheet to protect them. So literally be a sheet of clear plastic. You can now there's now materials available so you can spray over them and do what's called a conformal coating. And the acrylic sheet used to reduce efficiency by 3 or 4%. The conformal coating only by about 1%. So you're able to do these boards slightly more efficient on a basic LED level. They're less expensive to produce because the light source is spread out and it's easier to get the heat away from them. And you can now protect them in a very simple and easy way by spraying them basically with acrylic lacquer over them.
Yeah.
And that protects them against damage and water and all that stuff. So between all that, I think they're now they've surpassed cobs, and that's why I've invested in an SMD design for our current model.
Well, I'm glad you said that because I hate it when somebody will channel out of respect, and I know that you're much more knowledgeable on LEDs. My belief was that SMDs have taken over cob, and it's just nice to know that the research that you've done is being backed up by somebody else who does a lot of LED research. So that's good to know. The cobs, just in case people I don't use LEDs and haven't really come across them. Really, you can correct me if I'm wrong, but the cobs, you'll be able to tell them because it looks like a big yellow square, doesn't it? That's how you can sort of check to see if the cobs and the surface mounted device LEDs, the SMDs, you can actually see the individual chips on the aluminium board. So that's how you can quickly check if it's a cob LED or the surface mounted LED. And if you want to have a quick look at what an SMD device is, on your channel, Shane, MIGRO, is it the latest video, the new MIGRO Array? Is that the first LED that's been produced with the SMD chips?
That's it. Yeah, I just dropped a little sneak preview of it. So it's not showing everything in the best light and all that stuff, but excuse the pun, but yeah, it's a little sneak preview of the new model. So you don't get to see the LEDs too closely, I think, in that. But yeah, on the channel you see quite a few. Nearly all the grow lights I've reviewed in the last 6 months are at that SMD type, usually in LED bar light form.
Yeah, I was going to ask that question, to be honest. Why is it that the majority of LEDs I've seen being released in the last year have been these strip LEDs? Is there a reason behind it? Is it because they're fashionable, or is there a genuine scientific reason for it?
Well, if you think about it, so there's two ways of basically two forms you can do these boards into. You can do like a square or a rectangle board, and a lot of people do them. They're very cheap form to do. They're an aluminium plate with the LEDs mounted on, sort of spread over them evenly, and a couple of wires hanging out and a couple of clips for hanging them, and off you go. They're fine, but they're very so the wires aren't insulated and sealed. The LEDs aren't insulated and sealed. They're a raw product, and they'll get the light to you. I personally wouldn't want to be selling that form purely because as far as I'm concerned, it's not finished light. It's not sealed. The wires are, terminals are exposed. It's just not a full consumer product.
Yeah.
In order to make them really protect them properly and give them a long lifespan, as far as I'm concerned, you need to make sure electronics are dustproof and waterproof, moisture-proof. So with those boards, it's very difficult to do that without putting them into a box. And when you put them into a box, as I said, with an acrylic cover over them and all that stuff, you reduce their efficiency and you make them more expensive. So people have been doing them as cheap as possible, but I think it's too cheap and not really covering all their requirements.
Yeah.
They should meet. The bars, it's easier to seal them. So with the bars, you basically that same LED board is in a longer, slimmer form, and you're fixing it onto an aluminium heatsink, so a long bar with fins on the back. And that aluminium heatsink allows you to plug a gland into it for a cable.
Yeah.
It allows you to put the hanger hooks onto it. It allows you to properly get the heat away from the heatsink. From the SMD board, and allows you to put, in some cases, acrylic covers over them, and in other cases, to spray coating on them and have them protected. So the bars enable you to spread the light out, but also to protect the LEDs and to seal the wiring. So
perfect.
it's a double job.
Yeah, you mentioned dust and water there. Correct me if I'm wrong. What's the IP40 and what's the IP45? Which one's which?
So IP rating is ingress protection rating, and there's 2 digits. The first digit is the physical rating. I can't remember exactly how it goes, but by about IP40 or by 40, it's like fingerproof, so you can't get the specification. Actually gives you, it's like a little like a lollipop stick or something, and it says basically you can't fit this lollipop stick into the device, so the gap's not big enough to fit that in. By the time you got to IP50, it's kind of dust proof.
Yeah.
So the thing is reasonably well sealed. So IP5, the first number is sort of dust proof, and then the second number is about the water, how waterproof it is. And once you get over IP56, you're into splash proof. So it's suitable for an environment where you'd have water splashed around occasionally. So it would be suitable for putting it in your back garden, for example.
So what I was going to say is, this sort of goes back to the marketing bullshit question. You can maybe help me out here. At what point does the rating become pointless? So you're going to operate these in high humidity environments during the early stages. So you want a high IP rating. But if a company markets themselves as, let's say, IP65, or I'm not sure which one's fully waterproof, but a few LEDs on the market.
65 is suitable. 65 and above is more than suitable for a grow room situation.
Yeah. And there's a couple out there that will literally hold a shower over them and submerge them and say, look, our LED will work submerged in water and with a shower running on it. At what point does it become pointless? Do you know what I mean? You're never going to have a shower running over your LED.
Yeah, I used to do that. I did a bit of promotion with the last model of light where I'd have it submerged in a fish tank.
Yeah.
And it's just a promotional means of getting that.
But it's not going to cost
across.
Yeah, it's not going to cost the
person. Who's going to be
anymore.
growing plants underwater? Nobody. So, it's just a little trick. Think about old school. So HPSs have basically no ingress protection. So you screw the bulb in, you screwed it into a ceramic holder, and there's gaps all over that. You spray that with water would leak down and short it.
Yeah.
And yet we were all pretty happy running our HPS systems, and not many people had major problems, and they just avoided spraying water, and the light is hung up high anyway.
Yeah.
So you want to be really acting the to spray water there, and it was minimal issue. However, with LEDs and electronics, it's not necessarily about spraying it with water; it's about condensation.
Yeah.
And so if you have something hot in a wet room and that switches off, it'll cool and everything around it will condense onto it, and you end up with a board that gets wet, soaked, and then dry. On 24-hour cycles for as long as you have that light in the grow room. And electronics generally are not rust proof, so water ingressing into them will react with the solder and with the wiring and all that inside, and the connectors and everything else, and will rust them and they will fail. So anybody who's had, I don't know about cars these days, they're a little bit different, but certainly with older cars, if you left them out not running, generally you'd have problems with the electrics, and you would, because they wouldn't have ever, they would lots of condensation, and the electrics would basically rot. and that's what you're risking with your grow lights if they're not properly sealed. There is the added issue of splashing water around the place and shorting stuff out, but there's fuses and other things to deal with that. It's fairly unlikely you're going to fry yourself. It's much more likely that your LED is just going to stop working for reasons you can't quite understand after like 18 months. And if you spend, these things are expensive. You could be spending £1,000 on an LED grow light, and you want to protect your investment. So spending a few extra dollars on making or pounds on making sure that the unit is appropriately sealed and suitable for its environment is the right thing to do when you're spending that amount of money, I think.
Yeah, definitely. Thank you very much. We had a question, but I think rather than explain it on a podcast, hopefully you'll know sort of off the top of your head. It's how to size your grow light for your grow area. Now, it could potentially be quite an in-depth answer that you give. I was just wondering, now I'm thinking about it, I'm sure you've done a video that perfectly explains sort of how to...
I have, but it's old, to be honest, and the question is so broad, as you say, that's very hard to answer. I'll whiz through it, and you can tell me if I'd be too fast or I need to add to anything.
Yeah, no, not at all.
So there's a couple of assumptions. So first of all, there's a range of light intensity that people use in their tent, and so an old school guys would use basically a 600 watt HPS in a 4x4. And that would deliver you somewhere in the region of about 450 micromoles per meter.
Mm-hmm.
Hello, can you hear me?
Yeah, I can hear you.
Oh, sorry, there was a beep in the line. So that would deliver typically about 450, 500 micromoles per meter square per second. That's the par level.
Yeah.
So 450 micromoles per second. It is possible with if your environment is dialed in, your nutrients are dialed in, your temperature is controlled well, it's possible to push that up to 1,000 micromoles per meter square per second and get an equivalent increase in yield.
Yeah.
So you can squeeze a lot more than people would have done typically out of your grow area than would have been done typically with HPS. And really the limit in HPS was not actually light intensity, it was heat. So as you probably know, you could do 1,000 watt HPS in a 4x4 as long as you could suck that air through fast enough to keep the temperatures down. It wasn't the light intensity that was limiting the amount of light we were putting in tents. It was basically the efficiency and the heat output of the lighting system. So now that we've got high efficiency LEDs, we can afford, or we're able to push that light intensity up higher. People are now starting to drive up to that 1,000 micromoles per meter squared. I usually only recommend sort of 600-700 because I don't want to waste people's money, and I don't want them to buy 1,000 micromoles per meter square per second for their tent if I don't think that they have everything else dialed in.
Yeah.
Because that's a very high rate of growth you're looking at, and if it is, there could be another limiting factor, what I call it. So if you don't have your environment dialed in, if you don't have good genetics, if you don't have your good media and good nutrients, you're just not going to take advantage of that high level of light.
Absolutely.
The whole system is not going to perform to that level. So let's talk about the mid-range of about 750 micromoles per meter square per second. So that's generally what I recommend now. And in order to achieve that, you have to put a certain amount of wattage into that grow area, but that depends on the efficiency of your system. So again, I'll make another assumption. So a medium or a middle performance grower is probably going to be spending a reasonable amount on their lighting system. So they're probably going to be getting, nowadays, for reasonable sort of mid-range LEDs, you can get 2 micromoles per meter squared per second output. And that 2 is a measure of the amount of light the system delivers to the plant canopy, to the plants, per watt put in. So if I'm saying that I have a 1 meter by 1 meter area, and I want to hit 750 micromoles per meter square per second over 1 meter, then I need 750 micromoles to be hitting that grow area.
Yeah.
Now, if my efficiency of my system is 2 micromoles per watt, then I divide 750 by 2 micromoles per watt, and I need about 375 watts. So we're talking for medium efficiency LED about 400 watts per meter squared.
Yeah. Okay.
And that's hitting 750 micromoles per meter square per second.
Yeah.
So that's the short of it. The long of it is, you should, if you're going to a grow light manufacturer, they should know this.
Yeah.
And they should be giving you that information with test data to back it up. So
that's a great point as well, how to spot the bullshitters from the genuine companies.
Yeah, well, the way I explain it to people is, would you buy a car that didn't have its miles per gallon or kilometers per liter in its specifications?
Mm-hmm. Absolutely.
You know, you just wouldn't do it, because you don't want to discover how efficient it is after 6 months of driving it. You want to know before you put it in, before you buy it. And it's the same with your grow lighting system. They should be quoting you. So on the website page, the product page, or in the data sheet or whatever, they should say, this light is for a certain area and it's going to deliver at X hanging height in this area. It's going to deliver an average peak power level of whatever micromoles per meter square per second. And in fairness, most people that have good grow lights do that because they're not ashamed of it, they're not afraid of it. They're they're happy to promote the performance of their product. And most the lesser performing lights, usually they don't publish accurate data.
Yeah, and that leads me nicely onto the next question as well. So we've talked a lot about PAR, micromoles per meter squared per second, PPF, PPFD. So if you had to sort of put these measurements into two categories, what measurements should growers start to learn, and what measurements are pointless and can be misleading? Because we do get measurements that try and mislead people. So what is the main measurements that people need to take notice of? So
as you say, the key units here is PAR, which is measured in micromoles, and PAR is, as we discussed earlier, is basically counting the photons of red, blue, and green light that are landing on a particular point, and it's counting how many of them are coming through every second. And as I was saying, we're targeting probably that measurement to be about 750 micromoles.
Yeah.
That can range. So within the same grow area, that could be rising and falling from 250 up to 1,000 in the highest point, and back down to 250 again. But you'd be getting an average of about 750. The problem with that measurement is that in order to read it accurately, you need what's called a quantum sensor or parameter, which they're 300 or 400 quid, and that can be way more than the price of the light. So it's a bit of a push to expect people to be buying their own quantum sensors.
Yeah.
So you should know the units and understand they're the units you're looking for. But in terms of realistically how you measure those units or assess those units, you have to go back to the manufacturer or somebody else who is testing these lighting systems and measuring those units and mapping out how those units are distributed over your grow area. And again, it's a bit of the analogy I use for this is to talk about water. So if you imagine that you were watering your plants and you had a hose and you put it in the center of the tent and it's sprayed out everywhere, that hose is going to have a certain flow rate. So it's going to deliver a certain amount of water per second or whatever into your area.
Yeah.
But it's going to do it unevenly, or it can potentially be very uneven. So you could have, sodden pots in the center of the tent, and you could have dry pots at the edge of the tent. if that water isn't being distributed evenly. So it's almost as important to have an even spread of light around so each plant is getting more or less the same amount of light, and there's no one's getting really hot and none getting really dead spots or cool spots.
Yeah.
And the only way you can really thoroughly do that is by doing what's called a par chart or a par map. But what that is it looks a little bit like a weather chart because it's got those contours or like a geography map where it shows altitude and you can see mountains and valleys and stuff.
And these are the things that have got like the greens and the yellows and the reds, and they peak at the
I use that format at the moment. Yeah, so red is for higher and blue is for cool or lower power levels.
Yeah.
So what I do is I hang, when I'm testing, I hang the light over a grow area. I divide that grow area into a grid, and I measure the intensity in each of those squares, and then I show the intensity in all parts of the grow area. So, in a 4 foot by 4 foot, I'd measure them into 6-inch squares. So you've basically got 8 squares one way and 8 squares the other way, and 8 by 8, that's 64 measurements of power. So you're getting quite a clear picture as to how intense that light is right across that area.
Yeah.
Some people show a star or a diamond pattern, or just show the intensity in the center, and that's of no use to you. It's back to your water analogy. You're just showing where it is in one point, and it usually they'll show it where it favors them. So they'll show a power number at the hottest point right in the center underneath the light, but it doesn't tell you what it is in the corner, and it doesn't tell you what the average is across the grow area. So a power map or a power chart is, in my view, essential in order to be able to accurately assess the light.
Yeah. I love the rain analogy. I'm probably going to use that. So I hope you don't mind if I steal that from you as well for future discussions.
No. Because light is in photons, which is like individual particles, and water is in droplets. Yeah. And it just helps to use that analogy because it's in the same. Light is actually more difficult to assess, difficult to assess than water, because it's very hard to see differences in intensity just by looking at the light spread.
Yeah. It's very visual.
You need
the water analogy is very visual. So it allows people to, in their heads, we've all used a watering can. We all know what it looks like to water a plant. So it's easy to understand. I'm hoping, now this might be a bit out the blue, but you obviously know the measurements PPF and PPFD. Can you explain PPF, PPFD with the rainwater analogy?
Yeah, absolutely. It's something I'm working towards in upcoming videos, is to go back and redo some of my old
I wish I could do
grow light guide videos and use some examples like that to improve the communication and get it across better.
Yeah, lovely. So what PPF, PPFD, can those measurements be manipulated by manufacturers to represent a fake reading or a false reading? Can they be used wrongly?
Of course, yeah. They can just make them up, and they often do. So, I just testing a little light. It's actually a good little budget light, so I'm not going to rubbish it now. But most of the sort of Amazon-y type lights that I would pick up and test would have inaccurate information straight off the bat. So it would say, for example, it would give you a center measurement under the light at 18 inches or something like that. I put the light up. I put the sensor 18 inches underneath it, and it's much lesser figure than is on their website.
Yeah.
So that's happening today. It happens all the time. It's way too common, unfortunately. And as I said, they don't really get pulled up on it. One, because their stuff is cheap, and two, because and linked, I suppose, is who's going to buy a 400 sensor to with their €100 or $100 light or whatever,
So we're relying on people like yourself to do these tests for us and to do them honestly.
Yeah.
So there's a few misleading ones out there as well, and I'm hoping. Well, I think that they're misleading. I'm wondering if you agree. First one that's misleading, which can still be found on HPS and LED manufacturers, is lumens. I think it's a pointless and misleading measurement. What do you think?
So it can be useful. So first of all, light meters are much cheaper than quantum meters. And it used to be, so light meters read the modern white LEDs much better than they did the old HPS and metal halide and stuff.
Yeah.
So it used to be a bit of a dark art understanding what you were looking at with when you were measuring lumens from HPS and from mercury lamps and stuff.
Yeah.
It just wasn't reliable. And when we went to the blurple LEDs and all these different type of configurations of LEDs, they just went. They didn't give any sensible feedback at all.
Yeah.
However, on the white LEDs, as I was saying before, the sort of neutral white and cool white LEDs, they'll actually give quite sensible results and quite good comparable results. I actually did a test with them, and I have a little hack on the Instagram page and YouTube video, and I basically bought a $20 lux meter from Amazon, and I calibrated it to my quantum sensor, and it was really accurate. So this is with a white LED, neutral sort of white LED spectrum.
Yeah.
And so you could do that. You could try the hack. So, go on to Amazon, buy one of those light meters, or one of the ones I specified, and you just multiply what you get in lux by a factor to get power, and that's quite easy. But you can also just use them as a lux meter, and you can find out, for example, that I have by mapping out your area and taking measurements in the corners and measurements in the center, you can sort of balance the hanging height of your light to make sure that it's high enough that it's spreading out to the corners, but low enough that it's getting as much light as possible onto the grow area. So for 20 quid for a light meter, a cheap light meter, reading lux only, you can still get a decent amount of benefit because you can eliminate hotspots, you can optimize the hanging height of your grow light, which whatever light that is.
Yeah. So it works for some things, but maybe not others. What about
for lux overall? Yeah, it's old money really, and it's not really. We should be moving into power now at this stage.
Yeah. Yeah, because the argument is that you've heard the saying. I mean, lumens for humans, power for plants. Lumens are that designed to see for the human eye. We see light very differently than plants will. So if you use a lumens meter, it can be maybe a manufacturer could maybe make the readings look better than they are by adding a certain amount of light. Maybe it reads the green light a lot higher, doesn't it, than red or blue?
Yes, you're absolutely right. So yeah, a manufacturer could present their data with lumen info, and it may not be optimized for plants, so it could be a bit misleading.
Yeah. And then the next one is Kelvin. Now, Kelvin by itself is a great reading, but what do you think about trying to sell your light based on a Kelvin reading? It can give you an indication of the color temperature, but saying that it's got this Kelvin compared to another plant, to another light which has got this Kelvin. What are your feelings on selling lights based on Kelvin ratings?
Yeah, so again, it's back to what I said earlier on the color temperature. So color temperature is basically how much blue is in the spectrum, and a warm color temperature, and that's got a low number, so it'll be about around 2000 K. Color temperature would be a warm white with low amount of blue, and for home use or domestic use, you probably go up to about 6000 K maximum, which is a very cool white with about 30% blue. Plants, as I said, won't grow any differently in the full range in between very much. Yeah. So they don't really care. They will, if there's too little blue, so less than 5%, they will tend to stretch, and that's not a good thing.
Yeah.
But the difference in terms of the plant development between a 2500 K color temperature and 6000 K color temperature is very, very little. the benefits of having a cooler white is the colours come out nicer in the plant.
Mm-hmm.
So often, some people buy grow lights from me for ornamentals and stuff, and I would always say to them, get the cooler white because it's going to make those blues and greens and yellows pop against each other. Whereas under the warmer white, things can all look a bit orange and pasty and not interesting.
Mm.
But other than that, I wouldn't. I'd say they're all good after that. What's really important is just intensity. More light equals more growth.
Perfect.
And that's what we're all after. And it doesn't really make much difference after that.
Yeah, and it's sort of the point that you've made there is with the 5% below. If you have less than 5%, it can stretch, but if you have more than 5%, it can help to reduce that stretching. But if you go above and beyond with 10 and 15% below, it doesn't have that much more of a difference. And it lends itself to when you look at the light that a plant uses. It's on one of these graphs, on a bar graph, it'll show a little bit of red, and then it can take up a lot of the green area, and it'll spike in the green and then come back down to the red. That's sunlight. What I should say is that's the graph for sunlight, and that's the spectrum that the sun will produce. So over the billions of years, plants have evolved to utilize this type of light from the sun to its best. So there's a lot of green from the sun, and there's a little bit of blue and a little bit of red. And what that means to me, and you can maybe agree or disagree, is that plants they've got an abundance of green, so they haven't had to make their system efficient to taking in green, because there's a lot of it around in sunlight. But with blue and red, they've had to become very efficient at being able to be able to absorb that frequency of light. So when you give them that 5% or 10% blue and the 5 to 10% red, they're happy. They've got the amount that they have been biologically evolved to take from the sun. Do you think that's a good statement to make, or am I off the ballpark there?
Well, I try to make it even simpler. Is that plants? So back in the day, certainly for myself, there was occasions when I misallocated my bulbs, and I'd be growing with metal halide instead of HBS, and growing with vegging with HBS instead of metal halide and all that stuff. And then I grew through with blue and red LEDs, and with warm and white and all these different ones. And I grew successfully. As long as I had enough light, I grew successfully with all of them.
Yeah.
So that's,
it's just intensity.
Again, that's the long and short of it for me is that, as I said, as long as you got a certain amount of blue in there, after that you can mix it with green, red. You can have an argument for whatever you want. You can argue your case for whatever you're doing afterwards.
Yeah.
And you can do that. People can grow with all those different ones because the plants do not care.
Yeah.
They are taking up the energy, whether it's a blue photon or a red photon or a green photon. As long as there's a bit of everything, they just do not care.
Yeah,
so
they're happy.
They're not aware of what we get obsessed about. They're just gonna take whatever they get, and their little factories are gonna pump out glucose from whatever photons we throw at them. So there's snippets of science that are often taken up as being and they're run with in the wrong way. So there's not weird stuff, but there's things people latch onto, like putting their plants to sleep with far red at night, phytochromes and all this sort of stuff. And I usually say to them, look, if you want to spend that extra money to get more yield, just put in more light.
Yeah.
Don't worry about fancy control systems trying to put your plants to sleep with far red and waking them up with sunrise settings and all this sort of stuff.
Yeah.
Just give them more light, or get better feed, or control the temperature better, because you're far better off working on the basics and getting them right than trying to look for some sort of secret sauce or fairy dust you can sprinkle over it with light spectrum. Because as far as I can see, I certainly haven't seen any definitive proof that there's any magical spectrum out there that delivers more plant growth than would be relative with other lights.
Yeah, that's a good way of putting it, and it's applicable to every industry, every everything is, don't get fancy, just get the basics right and you'll do a good job. That's a great way to sort of round that bit off. Right, 2 quick questions. You're going to answer them truthfully. Other than your own engineering, what's been the favourite LED that you've tested?
So, different strokes for different folks is my answer for this one. It depends on what you're trying to achieve. So, to start off and say, if you're starting off, it's a bit like the advice back to car analogies, you know. When you're starting off, you don't have to spend too much to get up and running. You want to just get up and running.
Yeah.
And so a mid-efficiency, cheap LED light. So usually people start in a little 2 foot by 2 foot. You need probably around, 150 watts or thereabouts of those. And you should be spending no more than £80 to £100 on that first light to get you going.
Yeah.
And those lights these days will be, in efficiency terms, about 1.5 to 1.8 micromoles per watt. They'll be really good. You don't need HPS anymore for that size. In fact, the lower HID stuff, so 150 watt HPSs and all that, are a lot less efficient than the larger sizes.
Mm.
So at smaller size grows, I'm always going to recommend LED. I'm going to tell you not to worry about the spectrum and get one that somebody has reviewed somewhere with a bit of history. And the reason I say that is because there's lots of ones online that are sort of, what would I call them? They don't have, it's not growers making them.
Yeah.
And they don't seem to care too much about providing even accurate information on their website. So I get often asked, this light looks very cheap. Can you look at it for me? And what do you think of it? And I go online and I find that the basic information is dodgy. It's not telling you the amount of power consumed. It's promising. It's saying a 100 watt LED will replace 1,000 watt HPS and all this sort of shit. I see these all over the place. So there's lots of stuff to avoid. So try and find somebody somewhere. MIGRO channel, I do lots of budget lights in that range, which I'm happy to recommend. They're cheaper than mine. I'm happy to recommend them because I'm not losing any sales. These are people who want to buy something just to get them going and cheap, and I respect that. So there's one I'm testing at the moment. A Panuo. I'll have the video out in a few days, and it's 2 micromoles per watt. It's 134 watts for about £80, which is unbelievable.
Yeah.
It could be closer to £100, but it's in that range, and it's really cheap, really nice little light. It probably won't last forever, but you're not looking for forever. You're just getting going.
Yeah.
So that's the starting point for me. Then mid-range. So if you're using the lights for a long period of time, efficiency is important because you're going to get the payback of the efficiency. So efficiency is important on the larger lighting.
Yeah.
Spectrum, as I said, is sort of faded into the background because everybody's providing pretty much the same thing, which is just white LEDs.
Yeah.
So usually you don't have to worry too much about that. And as I was saying, I wouldn't bother wasting money on far red or UV LEDs.
Mm-hmm.
They're again, the analogy I use is, the old stereos you get, and they had all the sparkly lights on front, and the equalizer would flash up and down with LED bars and all that. What you're paying for there is lighting for a stereo. You want to pay money on the amplifier and the capacitors and all that stuff. You want to spend money on the sound that's coming from them.
Mm.
And in lighting terms, those UVs and far reds are doing nothing for your plant.
Yeah.
They're doing something negative. So don't waste money on them. Just get the basic, does what it says on the tin grow light.
Yeah.
That's another tip. And then size it right. So get enough. No point in getting a big grow area, paying for the big size tent and all that sort of stuff, lots of pots and everything else, and then underpowering it.
Yeah.
There's just no point. So try and get a light that specifies its output, gives you a power map, and then in order to understand how good value that is, you can just look. You can compare lights, for example. So look at a 500 watt light from this guy, and he's giving me this efficiency, and here's a 500 watt light by another guy at this efficiency. Multiply the watts by the efficiency, you get the output, and then divide it by the cost you're going to have to pay, and you can get micromoles per dollar. So the output of the light divided by the cost of the light, and that will tell you how good value for money. And again, I'm doing a best grow light 2020 video shortly, and I'm doing a table like that with all the grow lights I've tested and a comparison of the real value for money. So the output of the system divided by the cost of the system give you a comparable figure for different grow lights.
That's great.
But you can do it yourself. You can do it yourself if you sit down and a lot of times people are spending. You can be spending anywhere from £200 up to £2,000 on lighting your grow. And, so it's quite a big investment, and it's worth sitting down and doing the numbers. The last thing is,
go on.
If you get onto our website and email me, I'll do my best. I'll get back to most queries. If people query me in and say, I'm thinking of this one or that one or whatever, you compare these, just email me in and I'll do my best to get back to them.
That's great. So what's the website, Shane?
So it's www.migrolight.com.
Good. Go and check that out. Go and check out the YouTube show, MyGrow, the Instagram, MyGrow Lighting. And if you've made it this far, because this is, we aim to keep most podcasts quite light, and we drop bits of science. And I think this podcast has been great for me because we've delved into a bit of the science. And if you've made it to the end of the podcast, then you're probably really into your LEDs and your science. So for everyone that's still listening, what power meter do you recommend, Shane, that they could maybe try and buy? Because people listening right to the very end are into the shit, and well done.
So brand wise, is it?
Yeah. What brand power meter would you suggest to buy? What's a good one?
Yeah, for the larger grower, Lumitech have a new brand out. You mentioned it earlier. I was really impressed with it. I love the build quality. I love Lumitech because I grew with their ballasts for years, and they've never failed me. So the Lumitech Zeus Pro is an excellent light, very good value for money.
Perfect.
Couldn't recommend it high enough. It's beautifully made. Everything's considered. LEDs are protected, and the form, putting it together is a joy. Really good light there. The 600 watt, you can do high performance in a 4x4, or it'll do a 5x5 as well for sort of medium performance. So that's an excellent one.
Lovely. And if they were looking to measure the lights, what power meter would you recommend?
Sorry?
What meters would you recommend? What equipment do you use?
Power meter, really the only, you can get there's a Hydro Farm one, which is quite accurate for white light.
Mm-hmm.
It's about 120, 30 pounds, something like that.
Yeah.
Upper range would be the Apogee SQ500 quantum sensor.
Yeah.
You can just get the sensor now and plug that into a meter that reads millivolts, and that will cost you about £300. If you want to get the little handheld device that reads the signal for you and gives you numbers, it's about £450 for the kit, so it's not cheap.
Yeah.
As a hack, as I said, try the LuxMeter one. Details are on our Instagram page, and that's for a little bit of extra effort for about £20 or thereabout. You can buy one of these Lux meters from Amazon, and you can just do a conversion factor and figure out the power for very little money.
Excellent. Shane, we've been on for an hour and a half, and I just want to say thank you very much for your time. And I highly recommend everybody listening to go and check out the YouTube channel. Go and give them a follow on Instagram, and for more information, go and visit the website. Shane, I appreciate you coming on. Thank you very much for your time, and thank you very much for all of your knowledge.
My pleasure. Hopefully you can do it again, and we could be wandering off for a pint now.
Yeah, definitely. I'll definitely have you back on. Hopefully, it'll be a podcast and a pint on the next one.
Sound.
All right, you take it easy, Shane, and I'll speak to you again soon.
Right, thanks a million. Take care.
Take care. Bye bye.